Okay, let me explain how you go about using a Petroff Hauser counting chamber to calculate the number of bacteria that you find in a culture. So let's start off with a culture. So I'll just put a little flask up here. And as you'll see, I'm not a very good artist. So here's our culture. And the question that we're asking is, how many bacteria do we have in our culture? And let's just say that the culture volume, let's just say it's 10 milliliters. So 10 milliliters of culture. So what we're going to do is we're going to take out 1 milliliter and we're going to add 99 milliliters of media. And that is equal to a 1 in 100 dilution. Spell 1 in 100 dilution. Okay, so now if we take a small amount of our diluted sample and we put it onto a Petroff Hauser counting chamber, here is the chamber, and let's just say that we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bacteria. So 10 bacteria, and the dimensions of this chamber are going to be 1 millimeter by 1 millimeter, and we're going to say that the depth of the chamber, and obviously we'll do this to scale, but you get the idea. The depth of the chamber, so this dimension here, is going to be 0.1 millimeters. And so if we think about the volume of the chamber, that's going to be 1 millimeter by 1 millimeter by 0.1 millimeter. Now, we're already starting to run into a problem because the units of our volume of our culture, as you can see from up here, are milliliters, and what we have here is a volume in millimeter cubed. So the volume there is 0.1 millimeters cubed. If you don't believe me, just times 1 by 1 by 0.1, you'll find that's 0.1 millimeters cubed, because millimeter by millimeter by millimeter is a cube. So we've got a volume of 0.1 millimeters cubed, and we've got 10 bacteria in there. So let's just write 10 bacteria just to keep that in our mind. Okay, 10 bacteria in 0.1 millimeter cubed. And so what we need to do is to get this 0.1 millimeter cubed into cubic centimeters. And so 1 cubic centimeter is equal to 1 milliliter. So what we need to do is get our 0.1 cubic millimeter into 1 cubic centimeter. So all we're going to ask ourselves is, how many times must we multiply 0.1 cubic millimeters to get into 1 cubic centimeter? So this can be a little bit daunting because we've got a cube, and so that can make it a little bit difficult. So the first thing I'm going to do is get my try and get this into 1 millimeter cubed. And so to get 0.1 millimeter cubed into 1 millimeter cubed, I would times it by 10. And so that then gives us 1 millimeter cubed. Now times by 10, so I made the volume there 10 times bigger, which means that I need to times the number of bacteria also by 10. So what we now have is not 10, but 100 bacteria in 1 millimeter cubed. And so now we've got to get a 1 millimeter cubed into 1 centimeter cubed. And there are two ways that we can go about doing this. The first thing we can do is, based on the knowledge that 1 millimeter cubed is the same as 1 microliter, and 1 milliliter contains 1,000 microliters. And so if I times that by 1,000, I would end up with 1 milliliter. And so if I've times my volume by 1,000, then I've got to multiply the number of bacteria by 1,000, and so I would end up with 100,000 bacteria per milliliter. The other way that we can do this is we can just multiply up to get from 1 millimeter cubed to 1 centimeter cubed. So the question is, how many millimeter cubed goes into a 1 centimeter cube? So if we have a centimeter and we make it a cube, then that would be 10 millimeters so that's equal to 1,000 cubic millimeters in 1 cubic centimeter. So we've got to times our 1 millimeter cubed by 1,000, which means we would multiply our bacterial count by 1,002, and however way we do it, we end up at 100,000 bacteria per milliliter. And so that's per milliliter, but we want to know how many we have in 10 milliliters. So all we're going to do is multiply our 100,000 by 10, and so that's going to be 1 million per 10 milliliters of bacteria in the culture. And so the last step we have to do is take into account our dilution. So remember that we did this 1 in 100 dilution. So we had 1 million per 10 mils, but we diluted in 1 in 100. And so we've got to multiply by our dilution factor. And so 1 million times 100, that's just 1 times 10 to the 6th times 100. And so if we add 2 to the exponent here, then that gives us 1 times 10 to the 8th per 10 mils of culture, once we've taken into account the dilution factor that we did to start with.